Hi friends, happy holidays to those of you who are on, or will be on vacation. Every now and then we need to enjoy a vacation. For those of you who are preparing for a physics competition, we have a pretty interesting question. You can read this question briefly just to get an initial idea. A thin stick stands on a surface. Maybe it's a table, floor, or other flat surface. What is certain is that the surface is a slippery surface. Not standing perfectly, the stick is slightly tilted at a certain angle to the vertical line. Now we are asked to calculate, how much is the normal force acting on the stick just before the stick is released? Indirectly, we know that the magnitude of the normal force will have different values depending on the orientation of the stick. Of the many values of the normal force, we are only asked to get the magnitude of the normal force when the stick forms the initial angle. Not all angle values. Let's discuss. After seeing this picture, what comes to mind? There are many things. Just start with the simplest. Identification. Let's say the angle to the vertical axis is theta. Since it is the initial angle, we can give it the subscript 0, theta 0. The length of the stick is L, and the mass of the stick is m. Since we are asking about the normal force, we have to check what forces are acting on the stick. The stick is around the Earth. There is a downward gravitational force. The stick does not penetrate the surface of the floor. There is also an upward normal force at the bottom of the stick. As far as I know, these are the only two forces. A force acting on an object causes acceleration. This is the simple language of Newton's laws. N minus mg is equal to minus ma. Since the stick is moving downward, the acceleration has a negative sign. What if in the direction of translational motion it is positive? Mg minus n is equal to ma. We know that a is acceleration. We know that the direction of the acceleration must be vertical according to the direction of the force. In this object, this acceleration is still not so clear. Immediately after the stick is released, it will rotate with an angular acceleration of alpha. Note, the change in displacement from each point on the stick is not the same. Each point on the stick turns out to have a different acceleration value. Because this stick has a center of mass, we can choose the acceleration of the center of mass of the stick. The acceleration at this point is what is meant as acceleration. The problem is that the direction of the acceleration does not match the direction of the acceleration we mean. If the linear acceleration of the center of mass is a0, the acceleration in Newton's law equation is the vertical component of a0. The acceleration component is a0 sine theta 0. Let's read our equation again. Mg minus n is equal to ma0 sine theta 0. I know that you have taken a rotational kinematics course. In the language of angular acceleration, a0 can be written as alpha multiplied by half L. In this equation, there are two unknown quantities, n and alpha. We need one more equation. Since it mentions alpha, we will examine the rotational dynamics of the stick. Let's just write, sigma tau is equal to I alpha. Look at the movement of the stick once again. That's right, the stick is actually doing two movements at once. In addition to rotating about the center of mass, the center of mass itself is also moving vertically downward. So the axis is the center of mass of the stick. If so, the gravity force does not have a torque arm. Only the normal force has a torque arm. The torque arm of the normal force is this line. The length of this line is half L sin theta 0. For the torque sine of n is positive. The torque is n half L sine theta 0. You must remember, the moment of inertia of a thin stick rotating about its center of mass is 1/12 of ml squared. From here, alpha is equal to 6n sine theta 0 over ml. Knowing the value of alpha, we can definitely calculate the normal force. Just substitute the value of alpha into the previous equation. The factor on the right can be written as 3n sine squared theta 0. Now, add up all the factors that contain n. N is equal to mg divided by 1 plus 3 sine squared theta 0. This is the answer to our question. Maybe you have another answer. Happy learning, everyone.